you simply just create some tuple from scratch, and the tuple should consist of whatever your current cursor position is. Take this value here, keep that value there in the corresponding position, and create a tuple out of that. Okay, and I actually show you the syntax in detail in the tutorial. Okay, there's an overall picture of how you should do in a much more challenging case. But it's not too bad, is it? It's not too bad. Okay, so that's so these are the two cases for you to do the iterated pattern from the supplier point of view. And the exercise for you would be maybe take one of them, try to draw the bond diagram for that to see how your card, let's say in the case where that's how your card or generic book should fit into this diagram. Of course, apparently you have to, let's say in the case of the generic book example, you have to replace this card here by your generic book, generic book class. And here, the cursor, iteration cursor class should be substituted by the my iteration cursor, right? That will be more or less how your diagram should look like. Make sure you know how to draw that, okay? Because later on, if you are asked to draw a diagram in the exam or test, I will ask the TA to be picky about how you draw the diagram. So you got to get the notations right. But it's not too bad because that's just a model for you to follow. So just make sure you get the arrows right, get the diagram not so messy, and the TA will be happy, right? Okay, good. So that's about the supplier side. So now about the client side. So basically, we're just showing you how to use a cross feature. So I think I was up to here. So I'm pretty sure you're good for this particular one, right? So this one will compile because now we're in contracts and we're using the for all quantifiers. And we did this practice already in the last Thursday. So this one is okay. Let's have a look at a more challenging one. Okay, this one, I think that's where we stop. This one is also very important. Let me explain that in detail. Draw something here. Have a look at this for all expression here. Okay, somehow this guy here corresponds to the mathematical expression there. Okay, so that's a general template for writing an across for contracts. I think I mentioned this last time. So this here should be some value of type iterable, right? And I said before, implicitly, IFO is going to call the new cursor feature on this object here that you specify. And what's the type for a new cursor? That would be the iteration cursor, right? Okay. So this one would be iteration cursor. Actually, that's why you saw in when I was trying to demonstrate the lab exercise last week, I was trying to use the name cursor always just to make sure the name makes sense to you. But it doesn't have to be called cursor. You can call whatever name you like. Okay, so here, this will be something that returns a Boolean. As we saw from the last lecture slides. Okay, so in this particular case, you can see that we have one vertical bar, dot, dot, vertical bar, and then count minus 1. So if I say this compiles, then that means this expression here is of type iterable. Right? So let me put it here. So the syntax for you to learn would be this dot dot vertical bar. The left hand side should be some integer expression, and the right hand side should also be an integer expression, and the whole thing is going to be of type iterable. Okay? What it is trying to say is create some iterable interval. Okay? basically creating some iterable objects on the fly, basically. So you're trying to say, create some interval that's iterable from 1 up to including the accounts that count -1. Okay? So I'm trying to say if, let's say, the accounts objects here let's say this is the object that's pointing to your array. Let's say your list, okay. Let's have this. Accounts, let's say. So that's good. Okay, that's the accounts. List of accounts. So these are the accounts objects. Okay, so now what it's trying to say is create some cursor, that's create some iterable cursor that will actually go from 1 up to the count -1. So accounts dot count in this case would be equal to 3, right? So basically you would create something like a 1, 2, and 3. This is just informal, I try to sketch. Okay? So that means the cursor here, the cursor is going to be initially 1, and then if you go cursor the item, the first time will be returned back to you 1. Cursor the item the second time will give you 2, and then the third time will give you 3. So you're trying to use that to index into the list. That's the idea. Okay, so let me just draw that maybe more properly. So now, imagine that if this is your 1, 2, 3, and now you have cursor. It's some reference here to some interval here, right? So cursor the item, the first time will give you 1, and then it's a cursor the fourth, the second time give you 2, and then give you 3, basically. Now, what am I trying to do here? However, I'm trying to say accounts -1. So in this case, it excludes the third index, right? So that would be count -1. It would only give me 2, not a 2. Why did I do that? You can see what I'm trying to do here. So basically, you can see cursor, the item here, is going to return back to me an integer, as I explained. And we're trying to use that integer to index into the list. And then because it's actually an account list, so this will be an account object. And then let's say we have some ID for the account. So we're trying to say the ID is less than or equal to the accounts in the next position. Right? So what am I trying to check here? Let's try to run it through together. The first time, in the first iteration across, cursor, okay, we agree that it's only up to 2. The first iteration. So cursor item equals 1. So what we're trying to do is to say accounts 1, right? Cursor the item, and then less than or equal to accounts 2, right? So I'm trying to see the ID field. The ID field of this is less than or equal to that. That's the first iteration. Okay? Now in the second iteration here is similar. The second iteration here, cursor item equals 2. And then here we're going to say, I'll just say EECS accounts 2 less than or equal to accounts 3. So what is now this time checking is? Checking to see this ID here is less than or equal to this ID here. Okay? And this is why I only create an interval only up to count -1. Because if I did account over here without the -1, then I would have got 3 here, and then if there's a third iteration here, then I would say accounts 3, less than we go to accounts 4, and there's no accounts 4. So that would be some contract violation, right? So that's a trick you should really notice.
So this means there will be a cursor item +1. Because of that, you cannot make it the account.
Exactly. You cannot make up to the count. So okay, you kind of understand how this runs, but what am I doing here? I'm checking what? They're in order. Good? Agree? I'm trying to check to see if they are sorted in a non-descending order. That's exactly the precondition you should do for binary search. Okay? So I hope this makes sense. Please make sure you know how to specify this interval here. This might be new, but it's not too bad. Just make sure you understand the syntax. Vertical bar, dot, dot, vertical bar. I think you might need this a lot for the assignment. And also, I might just give you some for all expression here, or try to explain that in English, and then you have to write something like this to me. Of course, if I see loop here, you're going to deserve a cross mark, I think. I'm afraid to say. So please make sure you get the keyword correct. Okay, good. Any question about this? Yes.
You create a code terminal, but basically the dummies, how do you create it?
You mean how do you create the? Actually, the 3 should not be here. I'm just saying if I put a 3 here, then there would be some contract violation. So 3 wouldn't be here.
Yeah, but like in the coding, you are saying account count -1, right?
Yeah.
Which means you eliminate one account.
Oh, which means I'm only going from 1 up to 2. Because you can see accounts equals 3. So I'm only going from 1 up to 3 minus 1. So I'm only going from 1 to 2.
So you're not taking the last element of that account.
Oh, the trick is, because I'm always checking that the cursor of the item and cursor of the item +1. So I'm only, okay, I see. You say for I of type integer such that I is within this range, then it is the case that this predicate holds. So you only worry about those i's that satisfy this range constraint.
Oh, so the big dot means, what's the big dot?
It is the case then, or it is the case.
And
I'm pretty sure you know this, but I'm just going to bore you again. So x, this one is challenging, okay? So this one, this is actually what we want to do, as I give you the math and tell you to translate that into the executable contracts in Python. Apparently, we want to use across. However, each across can only introduce one cursor variable. Apparently, here in the mathematical expression, we need 2 dummy variables. So that means we need 2 across constructs that are nested. Okay? So, although I said that exercise, I'll give you some hints. You should really try it out. For any I and j of type integer, such that I is actually some valid index for the list, and j is another valid index, and I'm saying this is true. Okay, let me use a different line. This is the list of accounts we have. In this case, we have 1, 2, 3, and 4. We have 4 accounts in the list. So that means I can go from 1 to 4. J can also go from 1 to 4. Right? So I can be any of, so it's a member of 1, 2, 3, 4. Also J the same. 1, 2, 3, 4. And we are going to use all the combinations for I and J. How many combinations do we have in this case? I heard the
16.
16, yes, 16. 4 times 4. Okay, so we have 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3. Let's say this is I, and this is J. We're saying if the ID here, the count. We're trying to say the account here and the account here, if they happen to be the same, then that means I and J are the same. What does that mean? That means we can never end up this situation where we can then there's some theorem I'm going to show you. I think it will be easier to. One more 1990 theorem for you to remember. It's called contrapositive. E implies Q is equivalent to not Q implies not P. Okay? Think about the expression I write here is actually P implies Q. It would be easier for you to think about it if you actually convert that into not Q implies not P. Okay? So if you look at that, so it's like if it is not the case that I is equal to J, that implies it is not the case that accounts I equals accounts. It's much easier to see. But you should know that this here is equivalent to that because it's contrapositive when you're 1090.
Oh, yes, yes.
Yes, good. So what does this really mean? So let's say, given any arbitrary combinations of valid indices for the list, if the indices are different, that means the accounts stored there are different. What does that mean? Want to try? Give it a try. What does that mean?
Basically, two accounts. Like there is like the same
Yeah.
positive.
Yeah. So this is basically ensuring that in this list of accounts here, you have no repetition. And the sense of repetition is relative to how you define the is equal feature in the account class. And so that's why I use the tilde notation. Okay, so this is also a very useful use of the specifying contracts in IFO. You can do this in IFO without too much trouble. Okay, any more question about this mathematical formula before I give you some hints on converting this into IFO in the other way as I show on the board. But to understand the meaning, it's easier to use the other way. So it's up to you, whichever way you like. Okay, how do we do this in IFO? So hopefully, with the help of the last lecture, I mean the previous slide showed you about how to combine Boolean expressions together, you can have some sense. I'm going to show you. One variable, right? So apparently we need some nested across. Let's say have the first one first. Okay, just write out the template first. Across something here as, I think I need a space here. As something here. And here, should I use all or some? Or some. So all will correspond to the universal multiplication, and some will be to the existential.
Some of them. Should check for the sum of them, yes.
No, actually, you want to check all the combinations of the I and J, so that's why you need all. And by the way, if you have a look at here, when you say for all I, J, here, integer, it's actually the same as if you nest it. Say for every I of integer, also for every J in integer. So this might be easier for you to see how this corresponds to the cross. Okay? Okay, so anyway, that's just an aside. So we should use all, okay? Okay, so here we know that we need some iterable here. And we can use our new syntax here, vertical bar, dot dot, here, right? And we should go from where to where?
1 to the size.
To the size of the account, right? Over there, I already wrote here, accounts, account. As, you can say cursor 1, you can say cursor I, or you can simply say I, doesn't matter. What about I say I for now? So, however, you gotta notice that over there, I is of type integer. But here, I is of type cursor. That's difference. Okay. Now, so that's what we have learned so far. To use one fresh dummy variable I. How do we put the second one? Inside the all? Why can we do that? Why? I mean, is that really, will that compile? How would you know it will compile? So what do we expect here? We would expect some expression of type Boolean, right? So anything that's Boolean would be okay. And across all would be a Boolean, right? So it would be certainly okay if we do simply another across something as J, right? That's how you should think about it, actually. So write out the structure for the first one and then indent the second one into it. Yes?
I have a question, because some of them we're not looking at, like when I and J are equal, we don't look at them, so should we still use all of them?
Well, actually, that's okay, because in this case, they will be looked at, but they will simply return true in that case, so that's okay. Yeah. Because in the case where you're referring to the I happens to be the same as J, then of course the accounting will be equal. I think that's a valid concern. That's okay. Okay, so here would be exactly the same. One, vertical bar dot dot, account, right? I would write it as J. So now, here would be what you have to do. Just to remind you, you have to say somehow I dot item here, and also J dot item here. Why? Because I and J are iteration cursors rather than integer. That's why. This might be the most common mistakes you can make when you try to compile that in Apple Studio. Okay, so you have to say I dot item there, J dot item there to index into accounts, and you also have the implies in iPhone. Right? Okay? I'm confident you can finish that yourself. Any questions? Good. Okay, so now, I think at this one, so we have finished using the across for writing contracts from the client side, and now this is how you use the across for writing loops. And we actually covered this already in the labs, using the from until, and then we can actually return the new cursor for the iterable object, right? So we covered this already in the labs, so I'm going to skip this. Okay, and then you can also use the cross here, and because we're using the loop here, so that's why the whole thing will make sense, because the whole thing here across is actually an instruction. So that's why they can appear in the do implementation line. Okay, the third one, similar, okay, just using a cross again, maybe with a different example here. Okay, any questions before I move on to the why don't we take a 10 minutes break?